All right, so now let's go back to our two demonstrations. For both demonstrations, the difference between the means was 10. So in other words, our between group variability was 10, right? The difference is the within group variability, how much the scores varied around the means. For our first demonstration, conditions A and B, the scores were pretty closely grouped around those means. The range was 2, right? So they're all close together. For the second demonstration, when we had C and D, the scores, the range was 12. So the scores were much more dispersed around those two means, right? Um, so what I want you to recognize is that demonstration 2 had a lot more variability than demonstration 1. As a result, demonstration 1 is more likely to be statistically significant versus demonstration number 2. Because again, demonstration number 1, the ratio is 10 over 2, whereas for demonstration number 2, the ratio is 10 over 12, right? So this kind of visually shows you what's going on. For demonstration 1, there's very little overlap between the two groups. For demonstration 2, there's a lot of overlap between the two groups because there's a lot of within group variability. All right, so let's do some exercises to make sure you get this concept. So what I want you to do is I want you to look at groups 1 and 2, and then groups 3 and 4, and I want you to tell me which groups are more likely to be different, 1 or 2, or 3 or 4. So it's more likely that letter B, groups 3 and 4, are significantly different because there's not a lot of overlap between the two groups, right? As you can see, the means are farther apart in that second group, the B group, the B example, versus the A example, where the means are much closer together. And the within group variability is the same. It's just that the between group variability is much larger in B than in A. Right. So for A, there's a lot of overlap. For B, there wasn't much overlap. All right. So which are more different now? The two groups for A or the two groups for B? For this example, the groups in A are more likely to be different, again, because there's little overlap between the two groups. Whereas for B, there is more overlap between the two groups. So the variability for group A is smaller than the variability for group B. All right, so when we're comparing only two groups, the statistic that we would use would be a t-test. Now, to be clear, a t-test is only useful when you're looking at two groups. When you have more than two groups, a t-test becomes a lot less useful because the t-test can only look for differences between two groups. We'll talk about an f-test in 2 classes from now, and that is a statistic that you would use when you're looking at differences between the means of 3 or more groups. So for a t-test, use a table of significance to see if the ratio is going to be significant. I'm not going to get too much into that part of it. Now, when using a t-test, we have to calculate p-values, the probability of getting any particular t ratio if the null is true. So what does a p-value mean for a t-test? It's the probability of getting a particular t-value if the null is true. Remember, that t-value is simply the ratio of between over within, right? Larger t-values indicate that it's less likely for you to get that particular result if the null is true. Smaller t-values are more likely to occur if the null is true. So what you want to have is a large t-value. So when you think back to our hypothesis testing lecture, we're looking at that p-value and comparing it to alpha, right? So if our p-value, that's the probability of getting that particular t statistic if the null is true, if it's less than 5%, which is alpha, then we would reject the null hypothesis. So larger t-values result in lower p-values. So think of it as like t-values and p-values are negatively correlated. As t goes up, p goes down. Again, for the null hypothesis for a t-test is that the means are going to be exactly the same. The alternative hypothesis is that the means are going to be different from each other, right? And again, if the p-value for a given t statistic is greater than 0.05, then we fail to reject the null hypothesis. So in other words, it's very likely to get that particular t-value if the null is true, so therefore we won't reject the null hypothesis, and we will conclude that the independent variable had no effect on the dependent variable. If the p-value is less than 0.05, then that indicates that the probability of getting that particular t statistic is very unlikely if the null hypothesis is true. And as a result, we're going to reject the null hypothesis, and we're going to say that the independent variable had an effect on our dependent variable. So if p is less than 0.05, we can now say that the independent variable is what caused the two groups to be different from each other. So here's our t distribution. I talked about a t distribution a second ago. This is a t distribution. If you have degrees of freedom of 8, a t-value of 0 is going to be right in the middle of that distribution. So in other words, if you got a t-value of 0, it's very likely to occur if the null is true, right? So this would be a p of 0.5, so it's very likely to occur. And it's irregardless of what side it's on, right? Now, if we get a t-value of 0.3, we're a little less likely to get that to occur if the null is true, but our p-value is still at 0.39, so it's still very likely to occur if the null is true. Now, if we get a t-value of 2.45, again, it depends on the degrees of freedom, so we have 8 here, then we have a p-value of 0.02. Again, 0.02 is less than 0.05, therefore we would reject the null hypothesis, given this particular t-value. All right, so let's quickly talk about, not quickly, but let's talk about t-tests and how to make sense of a t-test in SPSS. So what you'll have to do at some point is you'll be given some output, and you're going to have to be able to interpret that output in SPSS. So if you run a t-test in SPSS, it'll give you these two pieces of information. The group statistics, so it tells you, so right here we have condition C and D. Both had 5 participants in those conditions. The mean for C is 50. The mean for D is 60. Standard deviation for C is 9.97. For D, it's 9.97. For the next, so that gives you some descriptive information. What you really want to look at is this next table here. This is where you're going to look to see if you have a statistically significant result. So what you would do here, this Levene's test for equality of variance, it's just basically testing to make sure that the variability around your means are not significantly different from each other. So one of the assumptions of a t-test or an f-test is that the variability around your means are going to be relatively equivalent. Not exact, but you don't want to have one condition where the standard deviation is really small and the other one with standard deviation is very large. So a default assumption for t-tests and f-tests is equality of variance. So this Levene's test for equality of variance is just testing to see whether or not your standard deviations are relatively the same. And because the standard deviations are exactly the same, we have a Levene's test, the value of 0, right? And that means that it's very likely to occur if the null is true. So that means we have not violated the assumption of equal variance with our groups. If we had violated it, so because we didn't violate it, we're going to use this first row here to determine our t-value. If we did violate it, we'd have to use this second row here But because it's not relevant, we don't have to worry about it. So we're going to go with the first row because we don't have a significant Levene's test. So we have a t-value of negative 0.1584. And that's saying our degree of freedom is going to be 8. 8 because we have, it's the number of participants minus 2. So we have 10 participants, 5 in each condition. So 10 minus 2 is 8. Those are degrees of freedom. And the probability of getting a t statistic of negative 1.585, if the null is true, is 1.52 or 15.2%. That is greater than alpha, so therefore we would fail to reject the null hypothesis. So in other words, the independent variable had no impact on the dependent variable. So again, I'm just kind of highlighting where to find things: the means, standard deviation, Levene's test, our t-value, our degrees of freedom, and then our p-value. And again, because that p-value is greater than 0.05, it is not statistically significant.